So then we go to the next speaker. The next talk will be Augmenting Structural Analysis with Programming and AI. And it's from Doğukan Karataş of Dlubal. It's actually very nice. He is the head of a Dlubal Software team in Munich, incorporating API and scripting, but also implementing AI on structural analysis. So this is quite cool subject, of course. So very thrilled to see it. Hi, Doğukan. Nice you're here. Are you ready?
Yes, cool. Of course. And it was a good introduction for me. Thanks.
No worries. So just a note to everybody, don't hesitate in asking questions in the chat already during the presentation so that we can moderate directly after the 20-minute talk. Okay, Doğukan, take it away.
Thanks. So, hi everyone. Let me quickly introduce myself first. My name is Doğukan Karataş, and I lead the API, Web Services, and AI team in Dlubal Software. Our team, our young and dynamic team, is based in Munich, and I prefer to describe our team as the innovation hub. And I'm certain many of you who choose to attend this event are well aware of construction industry is still old-fashioned when it comes to embracing tech innovation. Structural design and construction industry is still relying on practices from decades ago. So even though we are living in an era that every practice we have in our daily lives has been transformed by new technologies, right? So that's why today I'm standing here and explain how we as Dlubal Software are about to bridge this gap between the structural analysis and design and the modern tech world. Yeah. So let me start with my presentation here. Sorry. Yes. So here is the content of my presentation today. Maybe some of you are already users of Dlubal Software products, but of course there are some attendees who does not know about our company. These are the products we are going to. I'm going to show the products we are having, and then this from these traditional applications, I will jump into our new interfaces. The first one will be the web services and API technology that enables our users to have a remote control over our products, and also create opportunity to customize the structural analysis and design workflows. Technology enables us to create benchmarks in big data sets with a wide range of structures. So this enables us to unlock new features related to AI, which will be my next point. I'm going to talk about the integration of AI. And I will explain our two projects related to AI, and I will show a demo. This will be not just a presentation. I will show you live demos, maybe some code snippets also. And my last point will be our plans and what Dlubal Software Innovation Hub is planning to do in the next year. Then at the end, we will have a question and answer session. Yeah. So to who doesn't know about our company, Dlubal Software is developing structural analysis and design software more than 30 years. And with our new generation products now, we have more than 100,000 users in 95 countries. And we released our new generation softwares 2 years ago, and we are still working on new implementations. So the FM6 is the basis of our modular software that you can define structured systems consisting of plates, walls, members, and also furthermore, you can create combined shell and solid and contact elements too. And HTAP 9 is, on the other hand, is designed for complex calculations of beams, frames, and truss structures. And our section 1, our new product also, determines the section properties for you for any thin walled and massive cross sections, and also you can perform a standalone stress analysis in this program. And Arvin 2 is performing wind tunnel for the numerical simulations, and you can determine the wind loads on the surfaces, and also you can export these wind loads to RFM or HTAP. These 4 programs are our traditional desktop interfaces, and now I think it's time to talk for more exciting and new generation interfaces, right? So the first one is our web services and API technology. So web services are a type of API that distinguishes itself from the other type of APIs on their style and way of communication. Web services uses XML-based information exchange between systems. In our case, we use an HTTP technology called Simple Object Access Protocol, SOAP, to establish this connection, and which provides a standard method for accessing these web services. Our team has developed frameworks that enable the use of this connection in structural analysis and design. And these frameworks provide basic functions that allows users to use these comments and send some comments to RFM and get responses back. They are designed to be user-friendly, so even if you have minimal experience with programming, you can still use them. To illustrate this concept, consider the graphical user interface, so the traditional desktop application, like in the right side, which serves as a solver to you. And with a GUI, you're interacting with this program using your keyboard and mouse, clicking some buttons, menus, or other types of inputs, right? But with the API, a lot of software programs interact with each other. So you can control the program with another program. So you have a standard set of rules and protocols for this communication. I will now jump quickly into our GitHub repository. This is completely open source. You can go in, take a look at the source code, and also take a look at the examples, how we can do it. And of course, we have a developer documentation, which you can learn how to use it. Also, when you're using API, for example, how to create a line. Here is the line class and the parameters you have to use to create a line. I prepare a small example here to show you how to use the API and how you can unlock some features with the API. So I prepared this with Plot-Dash, which is a small web application I would like to show you. So imagine that you're working in a company, or you have a company that works with storage tanks. Often, let's say you have 3 engineers, and in the traditional way, everyone has RFM, everyone is starting from the scratch for every new project, and you don't have a protocol for it. Now, with the API, you can create a small web application like I did here, and install RFM as a solver in your private server in your company, or maybe a cloud server, and use this RFM as a calculation tool in the backend of this website, right? So let me open RFM here. I have my RFM open. I'll give 2 inputs, wall height, let's say 8, let's say 12 to diameter, and you can change the utilization here, and then press calculate. And then we will see how this website is interacting with RFM. Now it created a new model called responsive tank. It's creating the geometry and then generating mesh, and then calculation will start. And finally, we can get the results back. Okay, now I can see the result in my website, as you can see here. And this is a live 3D render on the right side. And of course, I just gave 3 inputs and 1 output for this small example, but you can customize it with your needs. I think it will inspire you to create your own applications with this API technology. I created a web application. Maybe you prefer just a simple script, or maybe a desktop application also. Yeah. And yeah, let me quickly go back to my presentation. So this is one way to use it. And having mentioned how our API is working, allows us to control this finite element analysis solver. It opens up endless possibilities for us, right? The most important possibility is that you can create benchmarks, big data sets, and for the structural analysis models. And when I mentioned data, I think you can imagine where this is going. Yes, with the data, we can train a generic algorithm to create AI models. The first point I'd like to emphasize that the integration of AI into Dlubal Software products is not a new thing. we already have a tool inside RFM uses AI for optimization. Our optimization of costs and CO2 emission estimation uses the artificial intelligence method called particle swarm optimization to find suitable parameters for parameterized models or blocks to meet the usual optimization criteria. On the other hand, this add-on estimates the model cost or CO2 emission by specifying the unit cost or emission per material. Now, in the past year, with the extraordinary development of AI technology, now it's time for us to integrate new projects into our programs. In this presentation, I'll show you 2 of them. For example, our first project I'd like to show is in-app help chatbot. Since we have a very detailed help and support documentation, we are able to train a large language model with our data and help our users to have better experience using our products, because Dlubal Software is active on customer support like 20 years, and we have a very valuable data set created by our engineers, like frequently asked questions, knowledge-based articles, also webinar scripts. Now it's time for us to use this data to create a neural network and serve our users non-stop inside the program. Our purpose is not build a simple question and answer bot, but make this AI-driven assistant empowering our users to maximize the value of our programs. This chatbot, I think it will be the first in the AIC industry, as far as I know. So maybe quickly go to a simple StreamMeet example with our chatbot. I'm going to open this StreamMeet, and I'm going to show how it's working really. So first thing I have to do is giving my OpenAI key here. And so I'm very excited about this to make it public, because feedback is always making support chatbots better. So this is now in just beta phase. So no user has used this, but we just created with this our own data. For example, I'm going to ask a question about Dlubal products. How can I create a multi-layer structure with a Python program? So I'm going to click ask. So it's a question about Python programming also, because I would like to see the code snippet in this example. I know this is in a website again. I created this website for this demo, but it's meant to be inside the program itself. So it's always a bit laggy when you're working with the web, but in the end, the final product will be inside the RFM6 itself. So it will be there always for you to ask some questions and get the answer. Yeah. So it gave me simply the Python script. Then in the next step, auto material is created and user-defined parameters, and it tells me how I can create the material and the others. Right. This is our chatbot basically. So let me go back to the presentation. So I have a more exciting interface to show you actually. So it is called text-to-model interface. You all aware how prompting affected information technologies in the past year. So we basically bring it into the structural analysis world. In our text-to-model interface, you can describe the alpha model you would like to have, and our natural language process comes in and create the model for you. What I can tell shortly about the technical background is our trained AI model is extracting valuable data from natural language input, and it identifies and categorizes the key entities such as location, material, section, and all other specialized terms for our user prompts. We call this process entity recognition. Then we are using these extracted parameters in a template Python script, and we send the script via our API to RFM to create the model. I have a small script web application for this too. And let's go get that Streamlit. Oh, sorry. Shell model. Yes. So now I'm going to give a simple prompt, and I'm going to check if it's going to interact with Arfem or not. Yeah, okay. Describe the model you want me to create. Okay, Arfem is open, so I can say, hey, generate a 3 meter by, let's say, 12 meter long shell with, let's select a concrete material, C4555 as material, and I don't know, 580 thickness starting from origin point 0, 0, 0. Yeah. And I'm going to click create, open the Arfem up. Sorry. So it will create a Neve model because, yeah, called shell. And model is under construction and done. Now I interacted with Arfem with an AI, and I created my shell. As you can see, here is the material. Here is the thickness I want, and here is the geometry. Maybe I can just quickly change 10, 5, and I don't know, change the thickness. Great. Oh, yeah. I'm going to have, maybe it's too small for it, for our data set. Now I'm going to change this, and yeah, you can see the geometry has changed. Yep. This is our text to model interface, which we are still working on because it's so important to have a clear data. Like you see, maybe we didn't go until that far, so it didn't recognize. So having a clean and wide range of data is very important to do it. So we are still preparing this data, and also we are training new models. So at the end, we would like to have a generative AI inside the program that you can mention anything inside the program and create models with this. Yeah. Now I'm going to go into my presentation to show you some last things. Yeah, these are the projects that we are developing and that we wanted to show in this presentation. And finally, I'd like to talk a little bit about our plans. This roadmap shows what projects we have related to AI integration and also what our timeline is. The 2 projects I showed in this presentation, I expect them to be ready in 6 months. Then our plan is to improve our optimizer with a Neve logic. And of course, since we have the text to model interface, it's very easy to us to create audio to model interface also. This is our plan too. That's actually all for my presentation. Maybe an announcement from my side is that since I have only 20 minutes to show here, so I couldn't go into the technical details too much. At the beginning of December, I'll be hosting a webinar where I'll be explaining the programming and AI integration, and I could go into very technical details because I have a lot of time because I'm the host of this webinar. So if you want to go in, you can just go our website and search for it, or you can scan this QR, and you can attend the webinar. That's all I would like to show for today, and thanks for listening. We can go for the questions, I believe.
Thanks, Doğukan. Thanks for showing this impressive work. Very nice developments. Maybe one to start with was one of the last questions that came in. You mentioned something on audio to model on the roadmap. What is that all about?
I already showed the text model interface, so you can give a prompt and it's creating a RFM6 model. Now we can interpret with the audio too. So you can tell, hey, create me a building with 5 floors. This is the columns, this is the materials. You can talk, and Arfem is going to create the model for you.
That sounds really great.
Yeah.
Cool. Let's see. I have 3 more questions on the board. If anyone still wants to ask a question, please do so. There's one coming in from Daniel Fuentes Cervantes. How reliable and accurate are the models created just by typing the instructions?
It's up to prompting. Think about ChatGPT. How reliable is the answers? This is just an AI. This makes your work fast and maybe creative. But structural analysis is not like creating some architecture models. You have to have strict and correct dimensions, materials, sections, whatever. But we are already using the data from structural analysis model. So if you give the right prompt, it will give you the right model to you. And also our plan is, if you would like to share your data with us, for example, you type the prompt and model is created. Now you can give us a feedback. Okay, this was my prompt, and the model was correct or not. So in this timeline, I believe the correction will increase in the future.
Cool. So let's see. There was one mention about being open source, which is really cool, of course, and it's mainly about the API, right? So
Yes.
Is it a true open source development? Can we also, let's say, put input on the code?
Yes, of course. We already have outside collaborators which are working with Arfem Python client, and they wanted to have a different experience, and they told us, hey, okay, maybe this part should be like this. It will be easy for me. And I always tell, okay, you can create a new branch on GitHub and we will review it and we can merge it into the main. So we already have this. I think we have a good community that we are always interacting with each other, with users and developers and other companies too.
Okay.
For example, we are also collaborating with VIKTOR on this.
Yeah.
And I think it's the most important thing that our API has. So everyone can go take a look at the source code. Hey, what's going on here? And everyone can edit this also, and everyone can create some questions, also give some feedback. And we are always taking care of this feedback in priority one.
Yeah, cool. That's good to hear, because I know one of my colleagues will be very happy to hear this. So he will be dying to collaborate. There's also another question coming in. Do we need to buy additional plugin or access to use Arfem 6 with the API? Or can you use it immediately when you have a license on Arfem 6?
Yeah, okay. So there's two type of scripting for Arfem 6. One type is, we call it in-app scripting. So you don't have to pay anything else, that you can just go in Arfem and do your scripting inside. But if you would like to have a remote connection, like a short, create a website and use Arfem in the background. So yes, there is a license called Web Services and API. You can buy it for 1 year, and you can use it in the remote. But as I said, when you have the Arfem itself, nothing more, still you can use the scripting inside without any remote connection. Yes. So basically, we have a license type called Web Services and API, and you have to have this for the remote connection.
Yeah. Okay, that's clear. And there's also a question from Emil Peltenberg. You might know him. Can you also change existing analysis models using the AI?
Existing analysis models with the AI? Yes, theoretically it's possible, I would say. I didn't try it. Emil is always creative about these questions. So yeah, I'm going to take a look, and I will reply him personally, I would say.
Yeah, cool. Do you send feedback back through the API during long calculations? So can users see the progress if the RFM installation is on a server elsewhere.
Yes, in the long calculations, usually inside RFM, there's a graphic that shows, hey, this how this calculation is going, also what's happening. So it's possible to receive this with API 2 into your program. Also, since every step is a code block, you can add some comments on these code blocks too. For example, hey, this is created. Now calculation has begun, and blah blah blah. You can add the comments to print somewhere in your maybe in your terminal or in your website. I'm always doing it when I'm creating something with our API. I'm always putting comments. Hey, now this is happening inside RFM, so I would recommend to do.
Yeah. Okay. Okay, that's good to hear. So then another question, do you measure how much the AI tools are used by your users? Are you using that to learn, to train it further?
By our users or by ourselves?
Yeah, so by your users. So if the users of RFM are actually using the AI, let's say, capabilities, do you measure that?
Yes. So I showed 3 AI projects related to RFM in this presentation. So 2 of them are in the beta phase. So it's just open for our beta testers. So we are always working. But the optimization of costs and CO2 emission is published like 2 years ago, I would say. And we have a lot of customers about this. And it's working very fast, in my opinion. So you can optimize a truss in just seconds, just I showed in the presentation. So we're always getting good feedback about this. But this question would be somehow related to, hey, how you're using my data. This is just up to the user. If they would like to collaborate with us, they would like to send feedback about the AI or other products, we are using them. If they say, okay, it's confidential, I'm not going to let you to use any of my models or my feedback, it's also completely okay. We are just going to ignore them. That's our plan.
Okay, sounds good. Yeah, so there was another question coming in, and I hope you understand this question well. It was about the trust design. Is neural network optimized construction parameters in your first example?
The first example, I think they're mentioning about the optimization tool that we already integrated in RFM. No, it's actually a generic algorithm. It's not a neural network. We used particle swarm optimization. This is not a neural network. This is what we called a generic algorithm. This is not a new technology. It's being used by the engineers like for 15 years maybe. So that's it.
Okay, that's clear. So now it's past, so we go into the break. So we can do one final question, if you are okay with that.
Yes.
Do you think this AI tool can reach a point where we can ask to optimize some elements based on results that we want?
Of course, this is the final approach. That's actually what we want. So in the model optimizer I showed in the roadmap, our plan is, let me quickly explain it. For example, you have a beam and you would like to have a certain point of deflection. So you can set these parameters in the AI model. Hey, I would like this much of deflection. Please create me a beam. So this is the final approach for all the elements and all complete model. You can optimize complete model with just one click. This is our plan.
Well, this sounds really like enabling engineers even better to do their work. So very cool presentation. Thank you, Doğukan. We are now going into the break for 15 minutes. So after 15 minutes, we will be back with the next talk, and it will be very interesting as well by Robert Otani from Thornton Tomasetti. On the Core Studio, they have accelerating ideas to applications. So see you in 15 minutes.